Okay, let's look at a few more integer multiplication problems. Maybe, let's try this one. Now, we could go left to right. How many negative signs do we have here? Just one. So we know it's a single negative there. Our final answer is going to be negative. And 5 times 3, there's 15. So I've used 1 3. 15 times 3, I know that from my clock, right? 15 minutes times 3, that's 45 minutes. And if you remember doing a little bit of trig in high school or geometry, 45 degrees times 3, 45 times 3, it's 135. Now finally 135 times 3, I'm going to have to actually multiply. 135, 3, 5 is 15, 9 plus 1 is 10, 3 plus 1 is, wait a minute, yeah, is 4. So 405. So I brought that negative down in kind of a loose way. And stick that where it needs to go. Negative 405. Now, could we have done that more easily? Definitely. If we go to a new operation, we can not only make the original problem more compact, easier to read, but in many cases, it makes getting the answer easier as well. You can probably guess what I'm about to introduce. An exponent, right? We defined multiplication most fundamentally, got my L there, as repeated addition. Well, exponentiation is repeated multiplication, right? In English, when you add the ation at the end, that means the process of, right? The process of multiplying, the process of exponentiating, using exponents, getting multiples, right? All these words are different forms of the same root word here. So 3 with that little 4 above it means I'm multiplying 3 by itself 4 times. Well, if I'm used to that, I may have memorized that. 3. If I'm not used to it, I can still get it here. Let's get my pen back. All right, so 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Whether I have 3 to the 4th power equals 81 memorized, which I do, maybe some of you do, or if I just ignore this 5 first, focus on all of the same factor here a bunch of times, maybe that's a little easier for me to do in my head. Now I'm doing 81 times 5. I'm still doing some scratch work. Maybe it's coincidence, but for me, 81 times 5 is easier than 135 times 3, right? I could do this in my head. 5 times 1 is 5. 5 times 8 is 40. So I get 405. And then that negative is following along with the 5. And there's my answer, right? Same problem, same answer. But it's a little smoother when I use exponents. Now we have to be careful with exponents when we're dealing with signed numbers. We have to really pay attention to what's what. So if I have another example here, I have a single 5. I have negative 3 to the 4th power. But do I put my dot and negative together? I should probably have parentheses. So if I slip those in here, okay, here, separating the dot and the dash. The question is, does it go over here after the 4 or here before the 4? And it's actually really important where that close bracket goes. This is correct. This is saying I have -3. What's inside the parentheses? -3 4 times. This expression is equal to the one above it. And that's usually how the problem will start. It will start with this more compact version, and you might actually want to turn it into the longer written, easier to understand version, because we can see I've got -3 times -3 times -3 times -3, 4 negatives and 4 threes. Well, we know those 4 threes together make 81. And then 2 negatives make it a positive. Back to negative, back to positive. I've got 4 negatives altogether, 4 negatives altogether. So I reverse negative, positive, negative, positive. I'm at positive 81. And then that 5 is just a 5. 5 times 81 is, we just saw that before, 405. Since I had 4 negatives, it's a positive 405. If I had a similar looking problem, -5 times -3 to the 4th. It's very common that people will say, oh, negative, negative, that's going to cancel out. But we don't have 2 negatives here. I have 4 negatives here, plus 1 more, for 5 negatives altogether. Right? If I write this out, -5 times 1, 2, 3, 4 negative 3s. If I'm circling all my negatives, positive, positive, negative. That's going to give me -405. We have to pay attention to how many negatives there are within this term, not just how many are actually written in its original form. So let's think about these parentheses, whether that -5 is there or a 5 is there, or maybe it's not there at all. Right? If we go to just a plain -3 to the 4th with no 5 in front of it, what happens if those parentheses are there versus not there? Well, we saw before that -3 really means -1 times 3. So before we can look at these problems, maybe we should step back from negatives and look at just plain 5. Do these mean the same thing? Or what if that 5 was there with the 3? Does this mean the same thing as the second one or the first one? Well, let's think about how our hierarchy of operations works. We'll talk more explicitly about that in a little bit. But right now, 3 is the base of this 4. This means I have a single 5 being multiplied by 4 threes. This means the same thing. What's the base of the exponent? 3 is the base of the exponent. So I have 4 threes. That's being multiplied by 5. Here I have 4 of what's right in front of the 4, a closed parentheses. It opens over here. So all of this is my base. I have 5 times 3. 4 times. That's not the same. These two are the same. This is now something different. Well, when I have a negative 3 means negative 1 times 3. This problem, the original one we're looking at here, means negative 1 times 3 to the 4th. It's exactly the same format as this problem. It's negative 1 times 4 threes. This version, that negative is inside the parentheses. It's part of the base. It's exactly the same format as this problem. I have negative 1 times 3, 1, 2, 3, 4 times. Right? That's not 1.3, it's times 3. In other words, I have 4 threes and 4 negative 1s. The opposite of negative is positive. Then it comes negative again, and that fourth one makes a positive again. We have to really pay attention when we're dealing with negative bases. Is that negative actually part of the base? Or is the negative just out front being applied at the end after we've already done the exponentiating? Let's look at a few more examples to make sure we're really solid on this, because this is a very common kind of mistake. So let's look at 6 minus 2 to the 5th, 7 times negative 2 to the 4th, 7 parentheses negative 2 to the 4th, and 7 parentheses negative 2 to the 4th. Right? 4 similar looking problems. I don't know why I switched from 6 to 7. That's what I had in my notes. But 4 fundamentally different problems here. Right? This is not a negative sign in the same way that this is a negative sign. This is minus, which means I have 6 plus a negative. But notice that negative is being applied to this whole term. Right? 2 to the 5th is 2 to the 5th. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, double that 8, double that 16, double that 32. I have 32. I have 6 minus 32, or 6 plus the opposite of 32. When I write it as plus the opposite first, it's not wrong, but I have to make sure that that opposite is being understood as applying to the whole term, the whole product, the whole result of all this multiplying that's abbreviated through exponentiation. It's not negative 2 5 times. It's 2 5 times. Whatever I get from there, 32, I now take it away. So 6, take away 32. The 6 is moving forward. The 32 is moving backwards. 32 is bigger than 6. I'm really doing 32, take away 6. My 26 to the right of 0? No, I was only 6 to the right of 0, and then I went a lot farther to the left. So I'm 26 to the left of 0. All right, little review of adding and subtracting sign numbers. If I wanted to show that on the number line, 6 forward, 32 backwards. How much is left? Well, this long arrow is 32. Take away this 6, that leaves 26. So the length of this is 26. My position on the number line is left of 0. So that's where it's negative 26. Right, notice the number line doesn't have to be super precise to be useful. It just has to help me see, okay, the 32 arrow is longer than the 6 arrow. That's good enough to recognize that I'm to the left of 0. Now over here, I don't have addition or subtraction. I'm multiplying. I have a single 7. So separate these here. I have a single 7 times the opposite of 2 to the 4th. Well, over here, that's saying the same thing. This is the opposite of 2 to the 4th. Here, I have 7 times negative 2 4 times. These are kind of odd ways of writing it. And in fact, it's kind of weird to have a negative in the middle of a multiplication problem. If we're doing this with variables, I wouldn't do x times the opposite of y to the m power. I would just recognize, okay, I have a single negative here. I stick that out front. I have a single negative here. Then I'm doing 7 times 16. I've got a single negative here. Then it's 7 times 16. I have 4 negatives here. Now I have to pay attention. 1, 2, 3, 4. The opposite of negative is positive. The opposite of that is negative. The opposite of that is back to positive. And now for all of these, I'm just doing the arithmetic. 16 times 7. 7 times 6 is 42. 7 plus 4 is 11. So I get 112. Positive in this case because I had 4 negatives, so I have positive. 112 again with that single negative brought in. 112 again. These two problems mean the same thing. This one is different. That negative is part of my base before I get to the exponent. Here the negative is out front of the whole thing. So I'm doing 2 to the 4th and then negative. Okay, so just pay close attention to where those grouping symbols begin and end and what operation they're tied to. Is it addition when we get to the 6 or multiplication when we get to the 7? You have to look carefully at those operations in the problem.